Hi, today my name is Andy William, and today in this video, I'm going to give you a tutorial about hashing. So, what is hashing? Hashing is a process or a function to generate a unique number that represents a value. That might seem vague, and you might not understand it. So, I think it's better to understand first why is hashing used. So, let us consider the problem of searching a traditional array. Say, so how do you search an array? Recall binary search and such. Remember that if the array is not sorted, like in this array here, the search might require examining each of the index. Like if you want to search 25, you'd have to start from the beginning, compare it to 12, compare it to 7, 38, until you get 25. So in this searching, you will have an average case of O, big O, N. Now, if it is sorted, then we can use a binary search. But even binary search have an average case of O log N. And but let's consider what is the fastest way for us to get the intended search. For us humans, it's easy. If we want to get like 25, we would just have to look at the array, or rather imagine the indexes, and see that 25 is located at the index of 3. So then we would just tell the computer it's on get index 3 of the array, and it will output 25. There, easy. Because we could know the index of the array. Now, what if we have a function that could tell us the index for a given value? Then, if we could know the index beforehand, the computer would have no problem of getting the value. It would have a constant runtime of O1, so just one search time. That's amazing. This is what a hash function is. Hash function is a function when gives a key generates an address in the table. Hash function is a function that to assign when gives a key generates an address. So say we have 7 that we want to put in the array, and it will be assigned a key which will then be converted to a hash function, and that hash function will generate an address in the array. So each value has a certain key. Now, how does it work? How do we implement this in the code? Actually, learning about why it is used is easy. Now, the hard part is getting how to implement it in the Java code. Okay, this is basically how a hash function works. So you have a set of datas. Uh, each of these objects have both values and keys. So this object has a key and a value, and also this object. And then a hash function works by converting the key in each object into a set of hash codes, which will then be modulo to the table size, which will keep it within range of the array, and then it will produce the final product, the final result of table indexes, and these indexes will be the place where the object will be put. So in this case, object 1 will be turned into will be put in the index of 4, object 2 will be put in the index of 1, and object 3 will be put in the index of 3, and so on. And that is basically how we implement hash function, in the Java code. And now I'm going to explain to you the code, the actual Java code. Actually, I've never explained a code before, so things might be a little bad. So I'm going to just share you the code in the description below later on. And yeah, I think it's better if you study the code by yourself, but nevertheless I'm going to try to explain it to you. Okay, so this is the code, and I'm just going to put this this image here to help you memorize, to help you remember what we should be doing, what our objective is. So we have the object, we need to turn them into hash codes, and in turn those hash codes will be modular to the table size. Okay, I'm going to begin at the main to help give you a clear picture of what we're supposed to be making. Yeah. I think it's pretty obvious here. Scanner scan, it's for the input, cout, hash table size. Okay, this is where we begin. System out print enter size. This is going to be like the array size. What do you want to have the sizes? Okay. Okay, so it will give you will have to input the size, and it will automatically create the hash table, and the hash table function is right here. Hash function. See here. Yep. Oh, wait a minute. Oh, this one. Hash table in TS the size, I think, and the original size will be this size is not the hash table. This size means like the what do you call it again? Like the filling, like what's inside it, how many objects are inside the table. And in this case it always begins with 0 because it's empty. And then table size will be assigned with the TS, and then we will proceed to create table new link hash. Oh, this is for another I will explain this linked hash entry later on, but let's just remember that we have created the table size as what we imputed. And then moving on, we do a loop here, so so the loop will keep running until we want to end it. Okay, we get to choose what we want to do. First, we're going to discuss about inserting the key and value. So each object, as we remember, has both key and a value. So we insert what is this? Wait. Oh yeah, sorry about that. Okay, so the input that we have here, and the next input here will be run into the insert function. So let's take a look at the insert function. Here it is. The insert function will have both key and values, and the first time that it will run the key with the myHash function. So this myHash is the process from object to integer, the process of turning the key into a hash codes. So let's take a look at the myHash. MyHash is right where it is. Ah, it's right above it, sir. So the previous key will have a hash value. Oh, and this is the interesting part. In Java, there's a function called hashcode. It will basically automatically turn the key into a hash code. So it's already built in the Java system. But you could build your own, but it's more efficient this way, and more useful, I think. Yeah. And then the value will be modulo by the table size. and then it will return hash value. Yep, don't forget to modulo it. And if the table is null, okay, this is another part of the hash function. It's called collision. Now what if we have 7 objects that we would like to input to a 7-sized array? It is very likely that one of the objects after the hashing and the modulo will have the same index number as another object. This is what we call collision. So what should we do? Well, there are 2 ways to overcome this problem. The first one is simply by moving it. Like if it's full, then check the next one. If the next one is not full, then put it there. If it's full, then check the next one again. So it's basically just moving, like checking the next array. But that is not very efficient because it depends on the size. So if you have a 7, so if you have like an 7, I'm sorry. So if you have a 7 array and you have an 8 input, you can't do that because there are too many inputs. Well, there is an alternative and more efficient way to do this, which is the second way. The second way is to use a linked list. So each of the arrays will be having a linked list. Do you get it? Yeah. Yeah. First time I don't really get it either. Okay. This is what I wanted to explain before. It's about the link hash entry. The link hash entry here. So this is where we create the linked list. The linked list will have a key, a value, and the next. So this is the object. This is our object here. Yeah, that's basically it. That's how we create a hash function. And get size is just getting the size here. Print hash table is yeah, not very important. It's just printing the hash table. Yeah. Oh, probably I want to how to get the hash table. So this is the get function. So you have the key, right? So say we already have this array here, and we want to get the object the second object, right? And we know it's in the first index, right? So you just bring out the key, type in the key, input the key, and the key will be put in the function, in my hash function modulo, and it will give the final result will be the index. And therefore you can just oh, I'm sorry. So the first one, if it's null, then it means there it's empty, and if it is not null, and it will check the linked list of the table, since we used a linked list as a means of collision. So yeah, that's probably it for my tutorial. I'm sorry if it's not clear enough. I think it's better if you just look at the code. I've put some comments in the code to help you understand a little bit easier. And thank you for listening, and I'll catch you up in the next time. Bye.